So, I hope the stream is working now. Still have some issues. I'm just trying to get my chameleon to work. And then we're basically ready to go. I make some space on my desk. So what I'm trying to do is to copy some music to my Turbo Chameleon, but it is very, very slow. So let's do it like this and see whether this is going to work. Now let's see if we have some play. Somewhere here. Let's see what happens. And we need some power for my Turbo Chameleon. Nope. So then we have to switch to a different view. It is actually not working as expected. I'm a bit disappointed, I have to say. So it looks like this Turbo Chameleon is not working as expected. So let's move on to plan B. And have some old-fashioned background music. So I hope this is working now. I hope this is okay, so we got some music. Not the way I have planned it, but well, I have to check what's going wrong here. Anyway, so as announced in the title, today's mission is basically to mod this NES with a component kit, and still have to change the audio a little bit. Otherwise I'm going to be a little bit confused because I'm checking my stream in parallel and get the audio from the stream, and there's a certain delay, and then I hear everything I have said about 20 seconds ago or something like this, and it's indeed a bit confusing. So yes, component kit, and basically what I want to try, I got some replacement ICs for my NES, and it's supposed to be a CPU and a PBU. The thing is, these are not original ICs, so I have to check which one is the CPU and which one is the graphic chip, because for this component mod we're going to put the graphic chip on the board, on the PCB directly, because there's not that much space inside the NES, which is indeed a little bit strange because it's a very huge case. But you may remember I have repaired my graphic chip a while ago and put this on a socket. And I have read in the installation instruction that this won't fit, so I have to come up with my replacement PBU, and for this I have to check which one is which, because they got different names. 65, 20, 38. I get a lot of flights, that's not what I'm looking for. RP2C07. Then let's have a look inside. So if this isn't working, then we can get rid of this. Get a little bit more space on my desk. So 2C07, 2C07. So that's supposed to be the graphic chip. And just to be on the safe side, let's check the other one as well. A6527. This sounds like a CPU. Let's see if we put NES. And the original is a PR2A07A. The tricky thing is that the NES has at least a different graphic chip as an NTSC version, so we really have to pay attention. That we are not mixing up those ICs. I had a nice page with the explanation, but let's just assume that this is going to be the graphics chip. Testing. There's a YouTube video. NES compatible PBU. Ah, okay, now I found it. Yes. So that's supposed to be the correct one. So let's see. Disconnect it. If we just remove this from our NES. And place this one inside. It's a bit too wide. I should remove the board completely, but I'm a bit lazy actually. Well, let's do so. I mean, we have to get it out anyway at a certain point in time. Just going to need the power switch later on. Oh, good evening, Mindflare Retro and Lars Henning. Hello. Everything alright with the stream so far? So, now let's try this again. Oh, I'm losing the first parts. Now we're making some progress. Now it's in. Nothing is bended. It looks good so far. Then let's see if it's still working. Oh, you got an NES for yourself as well. Yeah, it's great. I never thought that I'm going to be so excited about it, so I need some power for it. So here we go. But actually, yeah, I am, and it's a very funny. So it's a bit tight without the case. Got some power. Hi Herb. Where did I get that kit? Okay, let me check. So this is coming from, I think that was the page, let's check. So, I think I have Windows 364. I'm sorry for this. I was a bit confused as well. So basically, let's move on to the window. So here we go. That's the page where I got this from. It's a German page, but I think it's not going to be a problem. And if you click on Nintendo, no, VGR. Ah, here we go. Will and Tim's NES-RGB. And, well, we can fit this into a Famicom as well. Okay, so that's going to be a little bit challenging, but anyway. And, yeah, so it's available for the NES as well. And it's good that you came up with the question, because I'm going to need this installation instruction. It looks like it's only available in German, so I may go and translate the required steps then. And basically it is available in 2 different versions, so you can add some buttons to change the settings of this mod, or you can do this by your controller. And as you can see, it is not very cheap. It's indeed a bit expensive, and I was really having quite a hard time to decide whether I go for this or not, but I thought, well, yeah, I'm so happy with the NES, and I got a Famicom myself as well, that I really want to have a better graphic output, a better video connection, and therefore I thought, well, it's going to be worth the price, hopefully, but we will see. So let's post this here as well. And then, yeah, let's move on with this instruction set. But I'm going to switch back to the desk view. Because we were going to check whether it is still working. So that was the question, now I remember. Yeah, it looks like this. Perfect. That's good. So then we can move this away. Just have to remember that this is the CPU, and oh, there's a bended leg. Oh, there are a lot of bent legs. Okay. Well, I mean, this stuff came from China, and I don't care that much about leg bending and things, and it's really badly bent. And since I made already the experience that it is very easy. Yeah, it's pricey, yeah. And I think for our English guys, if you go and use a Google Translate or something like this, then I think it's going to be at least understandable what's going to be needed. And I mean, if you consider that you can get an NES Mini, for example, or an NES clone based on a Raspberry Pi or something like this for much less of the money than this component kit, I really hope it's going to rock. So I'm very disappointed with this bended legs here, I have to say. It's a nightmare. You can see this is how I have received it. And well, I may have to get in contact with this guy and have to express that I'm not happy. So I will leave it as it is right now to take some pictures later. Let's put it back in the bag and take care of it later. So, left a lot of dust on my desk. So These are two broken noses from a Famicom cartridge that wasn't working anymore, and I was trying to fix it, and I tried to open it, and there's basically a kind of technique to do so. I know I'm a little bit losing focus. So basically you can use some kind of a clamp and press the upper part of this case together. I was using this from my construction site. It's a bit dirty, but yeah, it's doing the trick. So basically like this, I have to pay attention that you really just get the upper part of it. It works a little bit better without the rubber parts. So and then you can press this and you can see it starts to bend. And if you do this heavily, then you can use a screwdriver and open the cartridge. But this plastic is already so brittle that even this method wasn't working. And so I ended up with a broken case, but nevertheless the cartridge is broken anyway, and as you can see there's nothing inside to repair. So I may check whether the wires are working, but beside this I did some extensive cleaning of the contact, so I assume it is broken. Anyway, that's the reason for this small plastic parts on my desk. Let's put this together. So, not needed now. So, this is working, okay, so we can use the chip. That's great. And let's remove all that stuff. And make some space. We can work on this. So I think that's going to be... I'm going to replace this anyway, because today I have received a replacement from eBay. Because I have constantly some contact issues, and I already checked whether the alignment is okay, and I did some cleaning and all that stuff, and then I just figured out that you get for about 3-4 euros or something like this a replacement. And I thought, well, yeah, let's test this. Something between the pins here. But it's not making any contact. Looks like it's just some plastic stuff. Yep, and let's see whether this is working better. So let's put this aside. And I'm not going to need this anymore. And yep, the reason for those two red wires is I bypassing this QIC IC, or is it just QIC? That basically prevents running cartridges with a non-European region code on this NES. And this helps a bit with contact problems as well. So if this IC, which basically is this one, and here I have applied the second method by just putting a socket on the board and then bending pin 4 out of the way, so that there is no contact to the board any longer. Is there any angle where we can see this? Perhaps this one. And that's basically doing almost the same like those two wires, but I was just testing if this is going to change something. Yes, as a major prerequisite to this component mod, we have to have our graphic chip on a socket, and this is going to be the most complicated operation, if I trust the manual, and I can, well, partly admit this. The NES PCB has very tight through holes, and if we just desolder from one side, it is almost impossible to suck all the solder material through those very tiny holes. And quite often you have areas with a lot of copper on it, and these areas are very, let's say, they require a lot of heat, and this was one of the reasons why I broke the first PBU on a different NES, because I haven't paid that much attention to it, and I was trying to remove it with a lever step by step until I figured out that one leg was still some kind of solder to the board, and by doing so I bended the leg, and while trying to bend it back I broke it. So that's the reason, and therefore I really recommend, if you're going to desolder the PBU from the board, I have used a certain kind of technique, so to say. I was using my desoldering iron on one side and my soldering iron on the other side to heat up the pin on this side and to suck the solder material through the hole on this side. And I worked myself through all those 40 pins, and this has worked quite well so far. But anyway, this step is done. Let's move on to the stack of parts. And as you can see, we have some stuff we are not going to need, like the socket, for example. And I think we have to do some prep work on this thing, because we have to solder those pins to the board. And basically, from a technical perspective, that's a very interesting project, because this is something like it's sitting in between the board and the graphic chip, and it is capturing the information sent by the CPU to the PBU, and this is trying to kind of recreate what the PBU is going to do, and then out of this it is creating the video signal. So basically this is some kind of PBU already, but it still requires some functions of the original PBU. It's not the FPGA PBU, which is available for the NES as well, but it costs even more, so surprisingly. But the main principle is almost the same. And the interesting thing is that the PBU itself creates a video signal, a composite video signal already. And if you have an component modded NES, there's a different modulator for this one, and which is quite common for the American NES versions, I've heard. Then the modulator is taking the composite signal and kind of converts it back to component video, which is, well, kind of a strange approach, but let's move on with this one. I'm just have a brief look at the manual. So we have to remove the PBU. Yes, we learned this already. And then we have to do some preparation. So we have a lot of different parts. We got 2 sockets. So, and this is probably going to be here. So maybe as some kind of outlook, I think I'm not going to solder the sockets to the board. I think I will have some kind of hot wired setup here, just for test purpose, because I need to drill some holes for those sockets in the case, and that's what I'm not going to do today anyway. So I think that will be fine if we just have a short test whether we can see something or not, and then I will do the fine tuning later on. So yeah, we have to solder some sockets to this thing. This has been done already, and now we have to solder the pins to this board, and we have to solder the PPU to the board, and I think we have to maintain a certain order. Let's see if we can crank this up a bit. So unfortunately the graphics are a bit smudgy. So let's just the length. Okay, this went quite well. And now we just have to figure out which one is going to be the PPU and which is going to be the socket. Don't like to assume this, it would be nice to know it. So on the picture, as hard it is to read, it looks like this. Would be really nice to have a sharp picture. Or at least a close-up picture. So, well, that's the step with the socket. I may just switch to this overview so that you see what I see. So basically they put this on the socket, which is quite okay. To have the alignment. Oh, it's tight. So, and then that's going to be the big question. I pretty much assume that this is going to be the first row where they added this socket connector, and then on the second row we have the PPU. So it looks basically like this. One step further. It's really tight, yeah. There's not that much space left. I'm not even making contact. And I think the issue is that my QIC is on a socket. So... no, that's not the issue. The issue is this capacitor, which is kind of blocked by this little board here. Oh, you can't see what I'm doing, I'm sorry. So, now I'm back. So if I put this on, then you can see that this capacitor is kind of blocking the installation of this board, so we may bend this a bit. And oh no, the other way. And yeah, now it looks a bit better, but we have reached the next point. There's another capacitor, this one. So let's bend them a bit. And now it should fit quite nicely. Except for my QIC, which is indeed too fat. So let's hope that the wire fix is working and bring this QIC back to the board without a socket. Hello, Qualinsha. I'm sorry when the pronunciation is wrong. I have no idea how to pronounce your name. Let me have a quick view. Just have to write a quick word here. Let's hope it's going to work. So then let's get out the socket. So we just have to remember that it was this way. It's going to be a bit noisy now. So the interesting option for this board is that we have a YC output. Some people refer to this as a SVU output as well. And going to be like this. So in case you do not have a component capable device or so, then we can go and use this YC connector as an additional option, but the main purpose is to use this BGRV 5V GND solder side, this connector, but I know that those so-called mini DIN connectors, or mini DIN connectors, to build a cable is basically a pain in the ass, and I have even no idea how to dismantle this plug. I think we have to press on a certain part and then we can maybe remove this. I will just apply some force and losing the first parts. Oops. Where is it? What was it? Something that holds everything in place. Yes, I was going to say to solder this is really not something I enjoy. So that's probably something I will do tomorrow or so. Let's put it back. Let me keep the parts together. And in the meantime, my desoldering gun has heated up. I will just mute the microphone for a while because it's very noisy. So microphone is back. Because there's an interesting thing which I can show you right now. So 3, 4, 5 pins were working very fine. So if I want to desolder this one, you might hear that this sounds differently. Well, it sounds different. And this is exactly the effect I was talking about. Some of those holes are really hard to desolder. And you really have to pay a lot of attention to heat them up properly. Another one. Bastard little. And the problem is that for a socket we cannot heat them up from the other side. And it looks like the whole row is going to be tricky. I've got one. So let's see if we can have some progress here. I haven't expected that this is going to be the challenge. Let's see if we can have some progress. So one side looks good, but the other side is going to refuse to give up. Nope, still soldered. It's really... Actually hard to see which one is still soldered. So let's see if we can... No way, no way. That's really strange. So looks like the ones in the middle. Can't make any progress here. That's really very disappointing. So let's try. If you can put some heat on the other side. The socket is gone anyway, so that's probably not something we have to pay attention to it. That's the one pin, yes. Just trying to avoid causing any damage on the board. There's still something not desoldered. This is impossible. Now we're making progress. Damn, this was hard. I hope we haven't killed something on the board. Looks fine so far, I think. Yeah. Oh, closed my chat window. Hi Wouter, nice to see you here. Yes, doing this live is indeed a bit, well, yeah, demanding. So, then let's put this back in place. And yes, while soldering, we have the very same problem. We have to heat this up very good, because some of those through the holes components, or pins, whatever we want to call them, are connecting the upper and the lower side of this, or the upper and the top and the bottom side of the board. And if you do not solder this properly through the hole, then the board might not work any longer. Interestingly, it's a bit easier to solder this than to desolder this, but you still have to pay attention. So, then CIC, not QIC. Well, I thought I read somewhere it's called QIC, but yeah. I just want to have one test if it's still working, not that we're going to bring on the component mod and then searching for the problem in the wrong place. So let's have one quick test if it's still working. Here, power and a cartridge. There we go. So, power, some light. Yep, still working. That's fine. So noisy. Okay, then back to what we had in mind just a few minutes ago. out of here. And where's my document? Success, yes. So we just put this back to the board. And then we place this on top. And now it fits perfectly. Yeah, feel much more confident. Confident. No, that was the word. The interesting thing is we can't lower the board too much because the pins are kind of avoiding that the PPU will fit into this perfectly. So we may have to find something in the middle, which I kind of dislike. Or do they cut them? Let's see. Solder only the pins on the outside, then do some adjustments. Okay, well, let's do it like this. So. I'm just going to solder the outer pins of this and then going to remove this because here we have the very same issue that through the socket we heat up the board as well, and this is consuming a lot of energy and may lead to soldering points which aren't perfect. So this was just for alignment purpose only. Try to get it out of the board again. Going to be a bit tricky on this side. And now we may have to let's see if we can squeeze it in. My little helper here. Got an idea. Let's do it like this. Just have to rearrange my windows here a little bit so that we have everything in one place. And then let's do it like this. Would you consider converting it to a top loader? Well, kind of. I have basically little bit something different in mind. I mean, if we have a look at the case of the NES, it's basically a waste of space. So around the board, and yeah, around the board there's a lot of space unused, and I have started to work on some kind of, let's say, slim case, which I want to print with a 3D printer, and I just want to use basically the screw points on the bottom of the case and just have a very small, let's say, space for cooling around it. I'm not going to assemble it with the metal sheets or the metal shields or whatever we want to call them, because they are just for compliance purpose only, and I don't care that much about compliance. And in this way I'm thinking about doing a top loader, but the problem is that the cartridge stands out very well high. Talk about those huge NES cartridges, and I mean, compared to the Famicom cartridges, they are really huge. And I just learned yesterday when I was browsing YouTube, I was looking for why my EverDrive isn't working with the Famicom, because it is supposed to do so. That there are some NES cartridges, they contain a Famicom cartridge and an adapter to NES, because Nintendo kind of decided that they just produce some Famicom cartridges and put them into NES cases, NES cartridge cases, which sounds kind of logical. I mean, adding the adapter and then putting this in this big case and you're done. But well, basically I do not struggle that much with the front loading system, as long as it is working. And you may haven't seen this at the beginning, I have received a replacement cartridge, whatever adapter we want to call this, and I hope this is going to solve the cartridge issues I have with this NES. I got another NES, very cheap on kind of an online flea market. It has a broken case, but it is working perfectly, so the adapter is working very good. And I think if we have a newer version simply, then it is working quite fine. And I think I'm going to use the NES with the EverDrive anyway, most of the time, so it's probably not really an issue of replacing the cartridges too often and having the original cartridges somewhere in my shelf as some kind of justification, or I don't know, is probably more than enough. So now we have this soldered, and maybe you can see that the IC isn't fitting perfectly to the board because those pins are in the way. And we may go and cut them step by step, but I don't know whether this is really a good idea. So they do not mention this, that they have check twice whether your PBU is aligned properly to the NES-RGB adapter. Yes, it is. So well, then let's do it this way. may have to find a position where it is somewhat aligned. I mean, I have to kind of admit that I like the NES really, but since I got this Famicom, I'm kind of in love with the Famicom because it is really much smaller than the NES, and it is really kind of cute. I mean, and the cartridge format is really kind of adorable as well. So, well, I haven't sold anything at all on this side. That was basically not what I had in mind. So I'm not even sure whether I spent so much time with the NES any longer. I mean, if this component mod is working very good, then well, yeah, indeed. But I may consider building an NTSC NES out of it, because well, the Famicom is NTSC anyway, so, and it runs at 60 Hz or 60 FPS, whatever you want to call this, and I have to admit that this is a very interesting experience, because you really see that a lot of games are running much smoother on the Famicom due to those additional 10 frames per second. And this is something I'd like to achieve on the NES as well. And this is going to be quite a complicated surgery, because you have to replace the PPU and you have to replace, I think, another IC, and I just found some kind of instructions somewhere. And since we have soldered the PPU to this board here already, we have to go through the same procedure, desoldering the PPU and bring it back to this NES-RGB adapter. So I may get kind of distracted by other projects and leave the stuff as it is. So let's have a brief check how our soldering is looking like. Quite okay-ish. We may add some additional material here to those pins. Okay, so one side is done. Alignment looks okay-ish. Then let's go for the other one. Funky, and they all have funky color cases. Yeah, that's really nice. So those cartridges are really cute. And well, I have kind of figured out how to open them, and I may, let me have a quick look. I found a YouTube video where a guy was explaining this. I may have this still in my history. I post the link to the chat. So, recommended by YouTube. There's a guy who is trying to mod an NES with a component installation. Wow, interesting. History. EverDrive. So, some Jan Beta videos. Here we go. That's the one I was looking for. Share. Copy. So. Here's the link. And I was exactly trying this method, but maybe the plastic is really too old and too brittle, or it may work when I heat this cartridge a little bit so that it is warmer and maybe the plastic becomes more flexible. Or I wasn't brave enough to apply so much force required to preserve those nose. Or whatever we want to call them, nose pieces or snap in, I don't know. And after crack open the cartridge, I just recognized that there is nothing to repair inside. So I was talking briefly about this at the beginning of this video. There are just two kind of blobs and no real ROM ICs or something like this, so nothing to resolder or something in this direction. So I assume it's simply broken by, well, time, aging or something like this. Unfortunately, it is the Super Mario Bros. Cartridge. And I was really looking forward to this one because I'd like to compare this to the C64 version and in 60 Hz mode. So I'm a bit disappointed that this one is not working. But maybe somebody is going to donate one to me, or I find one on eBay sometimes. But as I said, instead of spending endless money to those cartridges, I may go for an EverDrive and just be fine with this one. Although I'm going to miss those funny looking cartridges. That's right. So, this step is done so far. Then let's move on. Could it be a bootleg? Well, yeah, that's an interesting thought. Since I wasn't brave enough to open another one, I can check it. But it looks pretty official. I just had it here for a minute ago. And oh, I broke another nose. Okay, so piece number 3. So it has some, well, I mean, everybody can produce this. It has some Nintendo here on the PCB. It has a kind of official number. And yeah, I mean, in terms of production optimization, it makes basically not that much sense to use ICs with classic 3-hole pins or something like this, but oh yeah. I have no idea how hard it is to produce something like this. It looks pretty professional to me, but well, It's probably not so hard to produce something like this. I may find out when I have a replacement cartridge. Can't even close it. Well, let's keep it like this. So, let's move on with my instructions. So, capacitors, I've done so. Insert the NES-RGB board into your NES. Okay, let's do so. Then, if you have a PAL NES, jumper 4 and 7 with some soldering material. So, where is jumper 4 and where is jumper 7? Found jumper 5, jumper 3, jumper 7, okay, here we go, and jumper 4, okay. Jumper 4 and jumper 7. And we have to bridge this. Oh, if I just imagine that I have to reverse this for the NTSC mod. I'm still not sure. Okay. Soldering iron isn't working. Come on. I have some kind of loose contact or perhaps a broken wire or something like this. But most of the time it keeps working after a while, but today I still face constant struggle. And I'm not sure whether this is inside or if it is outside my soldering station. I checked the cable already, but maybe it's really the cable. Strange. So that's something I really have to address sometimes. Jumper 7. Nice shiny blob. Jumper 4. Same here. Next step. Connect your wires. So, now we have the part where we have to add this voltage regulator. So we need some wires. Okay, interesting. But it looks different to what they have sent me. Oh, okay. So I got something with 3 pins, but I have to add 4 wires. That's going to be a challenge. Next thing is I have no idea to which part I have to connect the wires. The thing is that this board consumes a bit more power than the NES wants to deliver to it, and therefore it is recommended to use an external voltage regulator to power this whole thing. And here we run into the very same problem like we had at the beginning. Those pictures are really hard to read. So actually I have really no clue where they lead the second black wire to. Maybe they have two ground connections. Let's check this. Yeah, we got two ground connections. Okay. So we have just one. Now we have to figure out which one is the ground connector on this board. There's nothing written on the other side. So one thing is that we Google for this type of IC. And this is a Murata i50115. DC pinouts Murata. Okay. No image. Okay. Datasheet. Typical unit. Okay. Features. Product label. Blah blah blah. Pin 1, 2, 3. Pin 1. Here we got pin 1 positive input, 2 common ground, 3 positive output. Okay, so let's check twice whether the number is right. Yeah, looks good. Then move back. We got common ground in the middle and we need 2 wires for common ground. So let's see whether we can find some wires. So I have actually no idea how beefy those wires have to be. But let's see if we can find something that is a bit more powerful than a standard DuPont cable. I think perhaps for the other ones they do not mention how thick they have to be. Well, maybe we do not need so big wires then. Then let's see if it is working with standard DuPont cables. So we can simply go for those are looking nice. Just have to pay attention that we are not going to mix up the colors then. And I think I got many of them, so need a black, a green, and some kind of whatever color it is, and another black. Okay, then I'm going to take this. Looks like my soldering iron is kind of dissolving itself. If I tighten my connector, then it stops working. If I keep it loose a bit, so I may have a problem with the socket here. So we're going to have a green, a yellow and a black. See if we have something to shorten this a bit. And another black. So, and we may put some shrinking insulation over it. So let's hope I have something on hand. Yep, perfect. Is it big enough for two of them? Yep, it's working. Very nice. So, not that much. Oh, I have to switch back. I'm sorry. I may create a view where we have the second camera in view as well. So let's just add a video capture device and go for this one. And then let's put this into the corner. So why is it called zoom and it's not zoomed? That's strange. Well, anyway, leave it like this. So you can at least see what I'm doing, and if I'm not referring to anything in the manual, I switch to this view and then it looks much better than before. So, and let's do this with the other ones as well. So let's say green input, yellow output. So I have to be a bit carefully because there are a lot of very tiny parts on this board that we're not going to break something. So let's try it like this. That's probably not going to work. Then let's test the other one. Just needs to stay in place for a moment. And we learned that, let's quickly go back to this view. Positive input is pin 1. So, and we said input is going to be green. Okay, input green. Nice and tight. Then we have black as our ground connection. Oh, stay in place. And yellow as positive output. So, I lost some of my wires, or my insulation material. It says figure, not very useful. Yeah, indeed. So, I think this looks quite fine. So let's just so, very good. I think I'm just going to kind of hot glue this to some part of the final installation. Now we have to solder this to our PSU. So, solder the wires regarding circuit diagram to this voltage regulator. Well, I have no circuit diagram, so let's check. If they have some additional information somewhere, but well. So this is indeed a bit disappointing that the information required are not really mentioned here in detail. There's a lot of assumption. Oops, a bit big. But this is a voltage regulator as well, and it is probably working the very same way as the other one. We're just going to put this in parallel and using the output for our board. So let's quickly Google if we can find a datasheet. Yes, here we are. It is available from different manufacturers. Mine just says Japan. Okay. Let's have a look. Sheet. So we look on this thingy like this. Typical application. Well, a pin layout would be very nice. I haven't seen it yet. Package dimensions. Ah, here we go. So, input voltage, it's probably going to be VI, ground, and V out. And we are supposed to voltage in and ground. So this kind of aligns to what we can kind of guess in this area, that they use those 2 left-hand pins, one for ground and one for input voltage. And I didn't follow the instructions. I should have done this before, but well, now let's do it this way. Oh, pretty tight tires. And another one. Draw the wires. What we are doing here. And this one. And this one. Then solder it. Indeed. Is it cold again? Kind of. So maybe my next live session will be fixing my soldering iron. Or maybe I ship it to Jan Peter and let him do it. So then let's see, input voltage, output voltage. Better check twice. Positive input, green, positive input, green. It's going to be here, still a big blob. And ground. So far so good. And, just for the sake of safety, I'm going to remove this and have a short test whether our voltage regulator is doing what we expect him to do. There was supposed to be a power cable just a minute ago here. Nope, well, this one. So, I still feel a bit uncomfortable with this voltage regulator open in this way, so let's see if I have some insulation material. Yes, so I may heat shrink this whole thing. I'm not sure about the heat dissipation then, but well, that's something we take care about later. So it would be nice to have some clamps. Yep. one and this one. And now if we're going to switch this on, 5 volts. Very nice. So still no smoke, still no flames. I'm pretty happy with the progress so far. Except for my soldering station. That kind of drives me crazy. So now we have to switch back to our instruction manual. And we are supposed to solder those wires to our board. And this is again some guesswork. Volt and ground. Okay, so basically those 2 pins. It's written on the board, it's just covered by it. So if you move back, let's go zoom. So if I lift this wire a little bit, we can see it's ground. And if I move the other one, then we can probably see it's going to be 5 volt. And that's basically the main difference. This is some kind of a communication interface, whatever we want to call this, because basically I'm going to be able with the buttons of the controller to switch through the graphic modes. At least this was kind of promised. So, and I'm not even sure whether I'm going to need this kind of functionality, but well, if we're going to test something that's technique and fancy, then well, let's do it in the proper way. So we have to solder this up again. That's really, really annoying. I could at least figure out what's the problem. I still haven't. Really looks like an issue with the connection here. So I may have to dismantle this. But the tricky point is going to be how to repair a soldering station without a soldering station. So let's see, we can get some material on this area, and that's going to be ground, and they solder it in this way. Okay. Pretty strange anyway, but why not? And the next one. Okay. Not very nice, so let's just... Yeah, much better. Running out of tea. Oh. So let's put it back. To the board. And I think it's about time to work on the final wires. So and they just say connect everything regarding the circuit diagram. But there is no circuit diagram. So that's going to be a bit guesswork now. I mean, we got this control, connector here, where we have BGR, RGB. But that's basically RGB, YC, ground, BAO. Whatever this means. And then there are some additional... okay, they connected this through the board. 1, 2, 3, ground. Okay, this is... we're not going to need this, so we just have to take care about connection here, YC, and a circuit diagram. That would be very handy. I haven't paid attention to the chat, I'm sorry. Jan will probably put in new caps and clean it with isoprop. Yeah, that's probably a good one. With a second one, but your desoldering station can also solder. Yeah, that's true. Yeah, I can use this to heat up the socket and then good plan. Yeah, thanks for that. So I really have to check. Maybe I got an email or so with the circuit diagram. Okay. Okay, I got a zip file with 22 pictures. Okay, then let's download this one and hope that this is going to help us. NES, here we go. Because the most important thing is that we have to know whether we are talking about an RGB, which is basically more than 3 wires, or if we talk a YPBR connection, because this is really having a major impact on the way we have to build the cable. And where's my folder? No, not the new folder. Let's delete this one. Okay, wrong directory. And there's supposed to be an NES folder, and there's supposed to be a NES-RGB folder. And there's a zip file with a lot of pictures. And then let's just open it. Strange view, properties. Opens with change XMU. Okay. And then let's make it the same way like the other one. And change window to window capture. This one probably. XMU. Okay. So sometimes it's really good to have a look at your emails. I have no idea how this is going to work because there are a lot of components on the other side. And okay, I see. They have replaced the voltage regulator completely. Oh. Well, this would have saved some time. And it makes indeed some sense to do so. But, well, perhaps I'm going to do this in the second step. Anyway, interesting. And here we go. Ground, RGB, and that's going to be the sync signal. So we're going to need an RGB cable instead of an YPBBR cable. And this is basically changing the whole concept. Because for this I'm going to need a SCART cable to connect this to my OSSC. Or we do it with a VGA cable. I may have some VGA cable somewhere. Not this one. Not going to work as well. And that's not RGB. Nope. Nope. So, well, then I have to look for a SCART cable, and well, I have to leave you alone for a moment because I have to look for this SCART cable. So I'm back in a few minutes, and it's a good chance to have some additional tea. So, I'm back. You need a be right back scene, Daniel. Yeah, indeed, that's a good idea. Time to grab the cookies and raise the music level. Oh yeah, I should have at least he left the tunes playing. Yeah, okay. So basically I found an SCART cable. Well, to be honest, I found many SCART cables in my video cable box. One thicker than the next one until you can't bend them any longer. And I was kind of thinking whether a VGA cable perhaps is going to work better, but a standard VGA cable cannot transfer, transmit, transport, whatever, audio, and therefore maybe a SCART cable is not such a bad idea. And then let's have a look inside. And so we have a lot of wires inside, and then we have to figure out what's going to be the layout of a SCART cable. And we have to pick... No, they are just... If it's two directional, we're not going to need all those wires. Just trying to figure out how we're going to solder this plug later on to this SCART cable. Let's go for this one. No, that one was better. I mean, the cable is almost thicker than the plug itself, and this will create a lot of mechanical stress onto the socket. But, well, there's no way around that. And just have to find a good length for it. Don't want to have it too long, because I do not have that much space on my desk. But on the other side, I have no idea where I'm going to place my OSSC later. So I consider moving it in the other corner. So we may go for, well, something like a meter or so. Oh hi, the Wikipedia. I haven't seen you coming. So that's basically, well, I'm not sure whether this is better on Twitch, but I can't see who is joining or who's watching. I may just have a look how many people are watching, but well, let's stay focused for a while. I think I go for something like this. Probably going to be enough. I can use the other half for the next project or so. So. And now let's do some dismantling. To be honest, I'm not really a fan of SCART cable. In my opinion, that's probably the worst connector ever. Because it is, well, so strange, and most of the time you have some bended pins, and it's not even standardized. It's just some kind of let's say mechanical format. And you can use the pins in whatever way you want. Okay, we can kind of pull them out. So we have basically all the pins available. But I have no idea how we're going to have access to them. So let's just hope that this cable has already what we need. And so got more cable inside. But that's probably going to be looks like this has been pulled out already a bit, so the build quality is not really so exciting. Well, I kind of assume that this is going to be the audio cable. So and this is hopefully going to contain our video information. And we got ground, shield. Probably that's going to be ground, and then we have the other 4 signals, basically sync and RGB. And this is what we have to figure out right now by doing some Googling, or maybe we just browse through the emails. So let me just show you what I'm seeing. Okay, here we go to replace the LED, something I haven't addressed now. And whatever he's going to do here. Out in. I think that's the reset function, okay. Ooh. That's quite complex. So I think that's something I will do later as well. Okay. Let's move on to the video part. Data LED clock. It's the LED, and that's the part where we talk about the cable. That's the voltage regulator. That's the socket. RGB out. That's a whole different socket he's using here, okay. Not this tiny whiny plastic thing I've got. Anyway, so this is not going to be helpful in terms of how a SCART cable looks like. So then let's Google up SCART pin layout. And here we go. So it looks terrible. Let's see if we can improve this a bit. And if it's mentioned somewhere, whether we talk about Oh, I have to change this. I see. Oh. As you can see, I see nothing. This side can't be reached. Well, that's something we have recognized already. Then just give up. Let's move on to the next one. Sega, Saturn, Amiga, Y-RGB cable. I found a Y-RGB cable in my box when I was searching for it. Just a standard SCART plug pin out would be very, very nice. Let's go for this one. So, now we just have to learn whether we are looking at this side or at the other side. Well, the shape itself makes sure we know what we are talking about. And the first thing I recognize is that this cable is using video sync out, video composite ground. But we have to go for pin 15, 11 and 7. Are these pins? And we need audio, which is going to be on this side. So these cables are audio cables, okay. Video sync out, video sync in. So this pin is going to be video sync in, that's the bluish one. So it looks like we have to rebuild this whole connector then. So let's see if we can dismantle this. And we can get rid of this one now. No, it's not working this way. And this isn't helpful either. Damn it. How to get out those connectors? Good question. Can we pull it? Can we move it? Nope. Something keeps them in place and we just have to figure out what. And then we have to reconfigure this whole thing here. But without knowing, I'm really surprised that they are very loose, but they stay in place if you're going to connect them to something, so they have to click in. Oh, well. How to get those thingies out of this plug again? Where stream information is consult anyway, whatever you want to tell me. Do you use OBS Streamlabs? I found that a lot better than OBS Studio. Well, I stick to OBS Studio right now. I haven't tested OBS Streamlabs so far. Not sure what's going to be the difference between those two programs, but I may give it a try. But first I have to understand. Oh, okay, it looks like there is a small nose on the backside of those connectors. And it looks that this nose sticks to the plug then. So we need something very small and tiny. So that we can... Oh. Ah, okay, I see. It's easier than I thought. Just have to press this little nose. We can see here on this part. And then we can push the connectors through the socket. I just hope it will move back in place and stay there after we have done this operation. Actually, I'm quite happy with OBS Studio so far. And I mean, I went through a long learning curve with this one. And I have tested other programs as well. But none of the alternatives were as intuitive as OBS. After you have figured out how to handle all your inputs. But, well, yeah, basically, I'm quite happy. So, now we have dismantled this whole thing. And now let's see what we have to do now. So, if we look at this like this, and that's probably the only advantage of SCART, you can't hold it in the wrong way, because you have this strange shape. Switching, we are not going to need switching, we need audio, right in, audio, left in, left mono in. So 2, 4 and 6, these are those 3 pins here. And we decided to use bus video RGB blanking, video sync in. Okay, so we decided that may have to renew this one. It looks really odd. But for the purpose of testing, let's stick to this. So, red is right channel. Then put this into right in. It's going to be 2. Let's briefly check the direction. It's going to be like this. And indeed from the other side. So, red to in. Like this. Then we have left in and ground in between. So ground. And left in. So far so good. Then let's move on to red. Ground. Oh, we are not going to need ground for every single color, so that's going to be a bit of a, well, guesswork, but no. And we need blue. That's going to be 1, 3, 5, 7. So let's get rid of this one. No, come on. And then we're going to need green. Just have to pay attention that we're not going to put this in our NES. May create some surprises we are not looking for. So this one. And you're not going to need the other ones. So. And perhaps video sync in is going to be 20. So now we have to decide. Video sync in. Let's go for white as video sync in. And we have to put it this way. Then we have red. That's the only color that matches. That's going to be 15. That's 2 from the top. And they are the other way around. Like this. Okay. 2 from the top. This one. And then we have ground. Let's put it just somewhere. And I hope it is simply kind of bridged in our OSSC. Otherwise, we're going to have some problems. The ground, I haven't removed ground, I just blue ground, red ground. Then let's go for this one. It's a bit closer to the other connectors. I used OBS for a while as well. OBS Streamlabs is basically OBS, but more geared towards streamers. It's worth testing perhaps. Well, yeah, thanks for the suggestion. I really have a look. Basically, I do not consider myself as a streamer, but well, on the other side, most of my videos are recorded in some kind of live, well, style or so. So it's really something that's bit more streaming than I may thought of. So blue and green. So what's closer to blue and green? So let's say yellow is green. No idea how I came up with this, but just have to check direction. I think it's this way. Yep, this way. And black is going to be blue. It has at least the same first letter. Black and blue. And then that's basically just one left, and that was the shield. And this is supposed to be our SCART RGB connector. Now we have to solder this to the other side and see whether it is working. So now let's move back to my menu and see if we have some clue about audio. So that's basically the graphics part. The LED. That's stuff we don't need right now, hopefully. Now we got a bunch of cables on this side. And I assume this white and red cable is coming from the audio on the other side, which is not described in detail somehow. So we have left basically RGB and sync. And then we got OAB. I assume one of it is going to be audio, but they are not the very same. So, well, let's figure this out later. Let's just try to get a video signal tonight. And if we got this, then I'm more than happy. And yep, I take care about the rest later. So. I may have this one as well. Not even sure whether it shrinks to this size, but well, let's test this. Better than nothing, I would say. So, soldering material. Real life calls, okay. Thank you very much. Thanks for joining. And then I will create some kind of condensed version of this live stream and put this on my channel. So if you have some interest to watch it again, then probably going to be a bit shorter. No cable search time and no trying to figure out where I can find the still missing circuit diagram. So now we can put this on the board. But for this we're going to need some solder material first. Just a bit scared of parts like this. Let's move them aside. So then we set, oh, I missed ground. Okay. Ground. Oh yeah, let's do it like this. Probably a good plan. Then we had white for sync, I think. May have made the cable a bit longer. Then black was blue. Oh, I hope this survives for at least a few minutes. Then we got yellow for green. And red for red. Only color that matches. Just have to get it in place. So, hopefully no short circuits somewhere. Then let's protect this stuff a bit from getting contact to my board. It's the least thing I'm looking for. Going to take care of this later. And then, we'll see. This is going to provide a picture. So, just going to put this into my OSSC. Like this. Then this is everything is fine. Our voltage regulator, a safe place. Then we may have to put this back so that we can have at least one cartridge inserted. And then where's my test cartridge? So, final check. And we're going to need this view. And we may have to switch to RGB. It's probably going to be this one. No signal. And we need some power. Oh. Hopefully it's not going to be too short now. It's an odd place, I have to admit. Fingers crossed. Let's see what happens. We got a picture. Well, and well, there's still some shivering, but nevertheless, it looks quite fantastic. I mean, we can have a chance and compare it to the composite signal, because I got my retro thing still connected. It's probably the situation where I'm going to screw up everything. And now we have to switch to... Oh, something happened. Oh, I moved the cartridge. Yeah, so... Okay. Why PBBR? Well, this is perhaps because we haven't enabled the video output switch. So, well, unfortunately we can't compare it right now. But, well, the main goal was to have a look at this one. And unfortunately I have no controller connected right now. So, let me see if we can have a quick and dirty controller. No, we can't remove this. There must be a trick to do so. Ah, screws on the button. Controller. And what just came to my mind, I think the audio may still work if we connect this to this one, and now we just have to connect this to this one. I hope that this is going to be controller 1, and we need a controller. It is still alive. So let's go for something that really looks awesome. Batman was a good point. Oops, wrong button. Dr. Mario. Oh yeah, Dr. Mario would be a good test as well. But where's Batman? Yeah. Start. The audio is basically not working because the cable is connected to the wrong adapter. And yeah, I see. I can't route the audio now. AV1. Now it needs to be connected to the SCART connector. Okay, so audio is not working right now. So I'm sorry for this one. But look at this picture. I mean, I'm not sure about this flickering effect. So it may need some fine-tuning of the OSSD, but the next one looks as perfect as it could be, probably. Item is providing some more information and a block diagram on his website. He's from Australia and developed that NES-RGB board. Thanks for the info. Yeah, I think that is where I initially came up with the whole thing. And then I was looking for a distributor somewhere in, Germany. And, well, I mean, I'm just kind of blown away. It looks fantastic. Oh. Oh. Ooh. Ah. I haven't played it for a while, so I'm sorry. And it's a bit unfair because I just see the synced picture of OBS, and it's probably going to be a bit delayed. But I'm so impressed. There's some stuttering every now and then. I think that's a sync problem of OBS. It's running at okay, it's running at 50.14 frames per second. That's basically the C64 frame rate. Keep jumping into this guy over and over again. Oh, there's so many of them. But well, yeah, it looks fantastic. So what else can we test? Do you have any recommendations? What do you want to see? Bubble. Contra. I was playing Castlevania. Yeah, it has some amazing graphics as well. So the colors are a bit strange. So I think I really have to work on this mode change. I remember that this was looking a bit different. So hard to go up the stairs. But, well, in terms of separation and, well, what's probably a bit misleading, I am running this with scanline option. So let's disable this. And now we have the full beauty of it. Want to buy holy water? No. Yeah, well, great. Bomberman, Bubble Bubble, Contra. Oh, dropped into the water. So yeah, I'm really impressed. So this is very close to what I was expecting. There's still a bit of shivering in the picture, but that's not really an issue. And at least this kind of sawtooth effect I've seen on the original NES at the border, you can see that the lines are kind of shifted in a bit, and this leads to some kind of distortion on certain games or graphics, whatever you want to call this, especially during scrolling. And well, Dr. Mario was already playable on an unmodded NES, but that's one of my favorites. But overall, well, I'm really pleased with the result. Need a red one. Here we go. So one thing. Let's have a look whether Klex is on the cartridge as well. That was indeed a bit hard to read. Galaga KL. No Klex. Well, Maniac Mansion, Metal Gear, Metal Storm, Moon Crystal. Paperboy. Super Mario. Let's have a quick look at Super Mario. There's some scrolling. So the pixel separation is really awesome. Well, compared to standard NES, it looks really fantastic. So yeah, I think the next step is going to be to get this socket connected to the board, and then get this VG or SCART cable into this connector. And fortunately we have enough pins to get the audio in as well, so we can have everything in one place. So the SCART cable wasn't a bad idea at all, although it is a bit stiff. That's something I'm not really impressed. And yeah, probably a good idea to use this PCB as some kind of adapter. And then going to hot glue this into the case, doing all the wiring, considering YC or SVU. That's probably an interesting option. Not sure where I'm going to need this resistor. I assume it's going to be a resistor, but well, maybe I will find some information. And then yeah, the two-color LED. That's going to be the next story of it. And putting back the voltage regulator to the place where it was supposed to be. Something I haven't recognized at the beginning. And then yeah, that's not a big deal. It's done within a minute or so. Anyway, I think the last thing I'm going to test tonight is adding the audio to the board, and then maybe adding those wires to the switchboard, and then testing the functionality of the switchboard. But I have actually no idea. Okay, the switchless mode is an addition where we can have start plus select plus A plus B is reset, and start plus select plus D-pad left or right, switching through the palette or the video graphic palette. Well, I think is it the right term? Well, yeah, palette. Well, color palette. Okay, yeah, that was exactly what I was looking for. So, well, I mean, let's go for it. So, first thing, remove power. That's important. Then I'm going to keep the wires on the board. I'm actually not in the mood to work with this plug right now, so that's really something which I have to do in a better mood, or whatever we want to call this. Soldering mini DIN sockets is very frustrating, and yeah, that's not what I want to do right now. So I think the first I'm going to get rid of is this mess. And we may disconnect the SCART connector from the OSSC because we may have some uncontrolled voltage or something like this. So it's my knife. Oh, I'm streaming for 3 hours now. I just have to check whether there's enough space on my hard disk. I haven't expected that. It's going to take so long. Gee. So there's enough space for another hour, okay. So I may remove something. Video station. Move them to this folder. And then I will have enough space for some more streaming, but probably not going to take so long to get this done. And as I said, I take care about the mechanics and the plug tomorrow. So, and we have to desolder the voltage regulator. And in the meantime, let's take care of this audio. It's really strange that he's not mentioning where I get the audio from. Because I think the audio is not available on the video chip location. Audio is coming from the CPU. Because that's a 6502 CPU that has been modified. And they added additional audio output abilities. It is actually called something like this, OPA, audio, AOP or something like this. I can't remember. Audio output, or AOC, audio output capability or something like this. Okay. So we may have to get it from somewhere else. Oops, got stuck to it. Okay, another ground connection that refuses to give up. So where's my screwdriver? Not so quiet in the channel. Somebody there still. So I may need this for another NES. I have one that's not working, and I got the impression that this may be related to the voltage regulator. So it won't move in smoothly. So let's try to get rid of some solder material. Or perhaps I'm going to change it to the same Murata voltage controller. Sounds like a good project as well. Still won't get in. Like the ground connector, still a bit too thick. Come on. So, here we go. So, looks good so far. Now, fix this one. And I think the audio is available on the other side of the board. But let's go through the pictures. Maybe we can figure out where he got the audio from. That's the LED hack. Let's reset. No clue about audio, so we may just grab it from the CPU or something like this. There's just one picture at the end of this whole thing. Oh, no idea where we can get audio from. I know it's on the other side of this video modulator. So if you turn it around, it's one of those pins. Ground, 5V. One is going to the power connector. Then the video signal, audio signal, and something else. So can't remember exactly which pin was doing what, but it's probably something we can find on the internet. So let's check. So I thought I had a bookmark. Yes, info program demos for fixing ultimate guide, interlacing, Famicom AC adapter. Let's start with this one. Music. No, that's just some download stuff. Okay. Cartridge hardware. ROM pin now. It's APROM, Mario. Console hardware. Hardware development guide. NES audio path. Okay. Pin 1, pin 2. From proc to audio output. Audio out. Okay, that's not really helpful. Pin 1, pin 2. Wherever pin 1 and pin 2 is. Okay, let's see what we can find. Family computer schematics, out. CPU, probe, ground. Sound 1, sound 2. Output for square waves 1 and 2. Sound 2 is the output for triangle noise and DMC. Okay, getting the audio from the CPU is probably not the best idea. So, NES audio path. I had the modulator schematic somewhere, but I can't remember. Probably in my folder. Let's have a look. NES. Fixing circuit diagram. Audio. Okay. And level audio out. That's not helpful. Line level audio out, so we may have to get this from the modulator directly. So, well, that's probably an idea. So we have to get inside the box. So, Well, that's going to be the audio. And if they combine pin 1 and pin 2 of the CPU, because of those different waveform outputs on the modulator, then I think the only place where we can get the audio from is basically from here, but let me check. If we go back to the NES audio path, we can see that we have two 100 ohm resistors here. Okay, that's this place. And then we have a 20k and 12k somewhere else. Okay. It would be nice to have not only the value but the label, the number of it. 20k and 12k. This could be everywhere. I would assume that they're not going to route the audio through the whole board to convert it in this place. So assuming that but if we're going to need this line level audio, then we have to get it from here. There's probably not a better chance to do so. So I may just solder something to this point and then route it to the socket later on, and now for testing purposes only to those two bodies here. So it's going to be mono audio anyway. Would be perhaps an interesting hack to get the audio, the two channels separated on left and right, and then do some blend or something like this. Could be another hack. So, but for now, let me check that I got some cable that I usually use for something like this. Yeah, okay. Now, may need this for something else. What about this one? This looks good. This looks fantastic. This is a cable that has been used for old CD-ROMs to connect the audio of the CD-ROM to your sound card back in the time when we had sound cards in our PCs and CD-ROMs with audio capability. And those cables are very interesting because they have some kind of a shield inside, and they are stereo indeed, and you have a separated ground from the shield. And I used this cable for my C64s when I add audio, like a stereo mix SID or a FPGA SID, and I want to have this audio in a different place, like on a 6.3mm jack. And that's a very interesting option. And you can get those cables for, let's say, I don't know, 2, 3, 4 euros, 10 pieces at eBay. And I bought a bunch of it and used this for other projects, and I'm going to use this for this project as well. So we just have to keep in mind the back of the console is on this side. So if I'm going to use this cable later on this side of the console, then I may just cut this in half. don't have to make this longer than we need this. And we're not going to use this side anyway. So probably going to cut this simply on this part. And we have to dismantle this side a bit. Where's my knife? Yeah. So quiet in the chat. I feel so alone. So, and let's use yellow for ground and just leave the shield option aside for now. So let's just remove this. And the other side as well. Okay, so far so good. And some soldering. I'm going to use this side on the modulator. So it's going to be ground. And this is our signal. Oops. Come on, guys, stay together. Okay, so far so good. Some soldering on this side. So audio was connected anyway, okay, that's fine. So we can put this on this one. And white to blue. Probably not the best connection ever, but no. it isn't the best connection ever, it's probably the worst connection ever. What the heck? I may have to make this a bit longer. Perhaps indeed a bit too small. Nope, won't go this way. There you go. So then let's try it again. No, come on. Can't be that hard. And one to here. So that's not nice, but well, hopefully going to do the trick. So let's move it back. Looks okay-ish. So, power cable. Fingers crossed. Power. No signal. So, good power. Haven't changed anything so far. Looks like it's plain dead. Maybe one. Yeah. So, well, what happened? Why isn't it working any longer? So let's see whether we still have some power. Nope. So we got a problem with our voltage regulator. So we know this is ground. That's input. And that's supposed to be output. 5 volts. So this is working. But we do not have the power on this side any longer. So maybe removing the wires wasn't a good idea at all. So let's have a look at the CPU pinout. We have power on the CPU. 5 volt and ground is 30, ground is 20. Oh, I have no access to it. Okay, let's assume this is ground as well. And 5 volts going to be here. We got 5 volt on the board, okay, but we do not have 5 volt on our video board anymore. Because, well, because what? Is it related to the audio? I can't think that is related to the audio. So, I don't think we screwed up the ground connection. Or maybe it's not happy to have no power connected to this one. Let's check the pictures. Let's check the pictures. There's nothing connected to here. So it should work this way. Or he's getting the power from somewhere else. In out. No, they do not modify the power switch, they modify the reset connector here. What's the white wire? Ah, the reset switch, okay. That's ground, okay. Strange, they removed the pin from here. I have to check this one tomorrow. And then they add the reset to this. In, out, okay. It's not 5 volt either. Well, yeah, strange. We have no power on the board any longer. It's a bit surprising. But basically I have changed two things. We moved the voltage regulator to this place. We got 5 volt on the CPU, so the voltage regulator is working. We connected the audio cable. But this is ground. That's the very same thing. That's fine too. Can't think that this is going to be it. this was supposed to be 5 volt. And this needs to be connected to 5 volt of the board, but it isn't. So we now have to figure out why we do not have 5 volt on this video board any longer. That's really strange, that's strange. And this is not really helpful either. Would be nice to have a picture of the board without the PPU, because there was a pin layout of the PPU. That's not going to be helpful in this way. I do not have the pin layout of the PPU. Ah, yeah, perhaps here. Okay. So, yeah, I found it. Okay. So, basically, let's move back to OBS and change this to XMU. Nope. To this one. So, pin 40 on the PPU has to be 5 volt, and we do not have 5 volt there. So this pin should be connected to here, and it is. Okay. And it is. And it is. And this is no longer connected. So I just hope it didn't blow up. It looks like there's a fuse. So maybe what I've done at the beginning wasn't the intention of and read it from this angle. Not sure whether it's supposed to be a... No, that's nothing. But it is right. It is a bit hard to assume if this is a fuse or not. I mean, I can simply pull the wire. Ah, I see. I see. Ah, you can see? Okay. I understand. XMU. So, let's move it a bit. Jump of 3 here. Got a solder blob. And it looks like the jump of 3 is an kind of an interruption of this connection. And since we do not feed 5 volt into here any longer, we have to make a blob here. Which hasn't been mentioned in the manual, because the manual was assuming that we are using a different voltage controller. So, well, that's a theory so far. And Come on. Just a few minutes. That's so weird. That's probably the socket. So, let's do it like this. And now, fingers crossed. That was simple, okay. And we now should have audio as well. Yeah, that was basically the first purpose of this exercise. So let's see if we can have something with nice audio. One moment, bubble bubble. Okay, mission accomplished. We got audio. Perfect. So then I'm not going to make the reset thing today. I'm not going to make the LED thing today. I may do the 3 wires to see if we have this palette change already and check whether the other palettes are looking a bit better. Let's say it like this. And then I think I'll call this a session, and then that's going to be enough for today. So we need some wires again. 3 of them, and they need to be a bit longer. Because we have to go around the whole board. This looks sufficient. Oh, 4 of them, okay. No problem, no problem. Oh. "11 people watching and nobody is saying something. Are you all asleep already?" Or is just my chat broken? Well, wouldn't be the first time. Let me briefly check this. What if I'm going to close this? Where's my chat? Here's my chat. Oh yeah, there's a lot of action in the chat and I can't see it. Oh, YouTube fooled me again. Oh, I'm so sorry. Oh, I missed so many stuff in the chat. Oh, I'm so sorry, guys. It was not my intention to ignore you. Oh, Citizen. How is it pronounced? Citizen or Citizen? Hi. Nice. Thanks for joining. Yeah. Oh, Wouter, you had a water accident over there. What happened? Still watching. Possible. I'm a bit tired. Yeah, I see. It's very late. I haven't expected that it takes so long, but yeah. As I said, still just going to solder these 3 wires, and then that's going to be enough for today. And hopefully I'm going to finish this tomorrow. I have to bring it back in some more robust shape. I can't keep it on my desk like this. So the strange thing is that I have used this pop-out function of the chat. You can, I think it's possible for you as well. You can run the chat in a separate window. I got a full bottle of water and tried to check a connector behind the TV. Oh, this sounds dangerous, yeah. Knocked the bottle over, half of the contents spilled over my desk. Oh, hopefully there was nothing sensitive on your desk. So. Oh, why came I up with this? So much solder material on it already. That's very strange, very strange. So, blue in the middle. And clock. Now we just have to learn, ho. Since I'm lagging the circuit diagram, I have actually no idea where we have to put the wires to, but maybe when we have a look at that's supposed to be which wire, I have no idea. Let's see if we have the CPU pin out, and we know that oh, let me switch to the window view. And CPU. So one is strobe. Nice that they have a different name here. Okay. And then the next one is probably going to be, let me check this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. OE joypad 1. Well, that's not really helpful. PS2, PS3, JAMA stick and some controls and my C64 Mini trying now. Oh. I really hope the best that you have no water inside and that it hasn't caused any damage. Was it mineral water? Then you should consider cleaning your devices with, how is it called? This special water without anything inside. Demineralized water or something like this. Yeah, I think so. Or distilled water. It's probably going to be the same. That you're not going to end up with some leftover stuff inside. So it looks like you're not going to make any progress with these wires. 1, 2, 3, 4, 5. Because what's written here is not the same as it is on the other end. So we can just assume that the top wires on the bottom, and they are crossed like this. But this is indeed a lot of guesswork. That's going to be on this part. So this is basically data. Latch and clock. Oh, haha. Oh, was tap water. Okay, there was some water inside the housing, but the board was dry. Okay. Well, and it's actually not a mobile phone, so if you have good access to the board and you see it's going to be dry, then hopefully not have too much. A piece 3, I've never seen a piece 3 from the inside, I have no idea. I think it's a lot of SMD parts as well. Doesn't sound like through the whole technology anymore. And the C64 Mini, well, yeah, it's SMD as well. Yeah. Well, yeah, I hope the best, fingers crossed. So, coming back to my project, I assume that this is probably going to be this connection. Damn it, a circuit diagram would be so helpful. And the middle is going to be underneath the other one. The middle. Wow. I can't figure that one out. So, no chance to see the palette change today. Inside, yeah, that's right. Yeah, the board is kind of floating inside the Mini. These two I'll test tomorrow. Yeah. It is already very late. So yeah, I have to write the guy. I really need the circuit diagram. I have no idea where I have to attach those wires here, and especially on the CPU, I have no balls to mess around with some sort of signals here, and therefore I may just skip this step, and tomorrow I'm going to make this reset modification and trying to get the socket into the board, into the case, and then I'm almost there. The two-color LED mod, yeah, that's something I may go for as well. That's basically not too tricky. There's another view, but that's not helpful either. Yep, okay, then that's basically all for this session. I think I will have a few minutes playing some NES games, but not too long, and then I will call this a day. It's 1:30 in the morning here in Germany. It's really late. It's really late. Noggle 2, okay. Broke my previous mobile in a full sync one time, yeah. Pushed it right away, turned it off, put it on the radio for 24 hours. It still lives on my in my car as a GPS. By the way, great NES-RGB picture. Thank you very much, yes. Yeah, this mobile dropped into something that's very common, I think. And that's basically one of the reasons why I prefer having outdoor mobile phones, which are able to withstand accidents like this. But yeah, this limits your choice of phones drastically. Anyway, so yeah, I think I have enough with this kind of solder attempts. I just put it back and then I will have some NES gaming before I fall asleep. So then let's mute the player for a while, switch to this view, power on that whole thing again, being happy that it is still working, and then let's go for a game. Bomberman, Bubble, Castlevania. Oh, I played the Goonies on the Famicom a lot. Let's have a look how it looks like on a standard NES. Just moving my OBS back into the middle of the screen. Oh yeah, the colors are a bit off. That's something I have to work on. Oh, too late. Oh. Got me. Ah, damn it. It is much slower on the PAL NES compared to the Famicom. That's interesting. I love the music of the first level, it's really fantastic. Ah, damn it. Can't jump from here. No. So let's move in this direction. Oops. Nope, that wasn't wise. So, just another key and then we have finished the first level. So the OSSC is saying that we have 49.99 Hertz. Oh, I wasn't paying attention, sorry. And OBS is running with 50.14. Therefore we have some stuttering. It's not synced perfectly, but that's something I really have to check if we can get this as smooth as possible. Yeah, too late. Ah, fatal, fatal. I have to pick him up, yeah. Forgot about this. Oh, dead end. Oh, I forgot the key here as well. Oh, how was that possible? Oh. Oh. That was really, really smart. Okay, anyway, let's call this the end of the video. As I said, thank you very much for joining. Thanks for all the comments. Thanks for the help. And I will make a kind of condensed version of this video and put this on my channel as well. And then I will hopefully finish the remaining parts here soon. And then I have a fully modded Pale NES with RGB modification, and it is indeed an RGB modification. It's not component, it's not YPBPR, what I thought at the beginning. And therefore I'm really happy that this works so nicely in conjunction with the OSSD. Then have a nice remaining weekend and see you for the next video. Thanks, Wouter. Wouter? Is it pronounced Wouter? I have no idea. Thanks, Highlander. See you soon. Bye bye.